What would happen if you combined creatine with the mineral that serves as a cofactor in ATP synthesis? That is the question behind creatine magnesium chelate. Creatine bound ionically to magnesium, typically in a 1-to-1 molar ratio. The rationale is mechanistically grounded. Magnesium is essential for ATP synthesis and function. ATP exists predominantly as a magnesium chelate, Mg-ATP in cells, and magnesium is a required cofactor for creatine kinase, the enzyme that catalyzes the phosphocreatine to ATP conversion. If creatine and magnesium are both part of the same energy system, delivering them together in a chelated form might produce synergistic benefits. The theoretical case has appeal. A combined molecule could potentially support both the phosphocreatine buffer and the downstream ATP synthesis chemistry more efficiently than either compound alone. And magnesium deficiency, which is common in athletic populations who lose significant magnesium through sweat, is associated with reduced exercise performance and impaired recovery independently of creatine. The clinical evidence is limited but exists. The most cited study is by Brilla and colleagues, published in 2003, which compared creatine magnesium chelate to creatine monohydrate in resistance-trained men over 11 days. Both groups supplemented at the same creatine dose. The chelate group showed similar strength gains to the monohydrate group, suggesting equivalent performance outcomes. The chelate group also showed less body mass gain, which was interpreted as less water retention compared to monohydrate. Less water retention with similar performance is a genuine differentiator if the finding replicates. Water retention from creatine supplementation is largely intramuscular. The osmotic effect of increased intracellular creatine draws water into the muscle cell. If the chelated form produces comparable phosphocreatine loading with less osmotic water accumulation, the scale weight increase would be smaller without a performance cost. For athletes competing in weight class sports where scale weight matters, this would be meaningful. The problem is that this finding has not been robustly replicated. A single 11-day study with a relatively small sample size in resistance-trained men is suggestive, not confirmatory. Independent research groups have not consistently reproduced the reduced water retention finding with the same strength performance outcomes. Magnesium's role in the energy system does not require a chelated co-delivery with creatine. Dietary magnesium is abundant in many foods and can be supplemented separately at far lower cost than creatine magnesium chelate products. The chelation chemistry does not appear to provide a delivery advantage sufficient to justify the premium. For the specific population who might benefit, athletes in weight class sports who want creatine's performance benefits with minimized scale weight impact, creatine magnesium chelate is worth considering as a hypothesis. But the evidence base is thin enough that it remains a hypothesis rather than an established alternative to monohydrate. For general populations seeking creatine's well-documented performance and health benefits, the substantially larger body of evidence for monohydrate, combined with its lower cost and more predictable water balance effects, makes it the practical choice. The chelate remains an interesting product that has not yet been studied thoroughly enough to confirm or refute its theoretical advantages. The magnesium component deserves independent consideration. Magnesium deficiency is common in physically active people. Sweat contains significant magnesium, and athletes with high training volumes can lose enough to create functionally low levels, even with adequate dietary intake. Symptoms of marginal magnesium deficiency include muscle cramps, poor sleep quality, elevated resting heart rate, and reduced tolerance for training load, all of which have a meaningful impact on training consistency and recovery. If you are considering creatine magnesium chelate, it is worth asking whether you actually need additional magnesium and whether a chelated co-delivery is the most efficient way to get it. Standalone magnesium supplementation in forms like magnesium glycinate or magnesium malate provides far better control over the magnesium dose and costs a fraction of the premium creatine magnesium chelate products. You can supplement both compounds independently at their optimal doses rather than accepting whatever magnesium content comes in the chelated product. The magnesium chelate concept is worth watching as research continues. If the Brilla study's reduced water retention finding replicates, that would be a genuine practical advantage. Until it does, monohydrate plus separate magnesium supplementation is the evidence-supported path for people who need both compounds.